Hi, welcome to the Chesapeake Biological Laboratory's Next Generation Student Interview Series. Today I'll be speaking with Maddy Lahm, and we'll be talking about why she decided to come to the Chesapeake Biological Laboratory, what she's researching, and how she hopes her career will develop after graduation. Hey Maddy, how are you?
Hi, I'm good.
Why don't you go ahead and tell us a little bit about yourself. Where are you from?
Well, I am from Lyme, Connecticut, and I actually went to a small undergrad called Wheaton College in Massachusetts. And so I went from Connecticut to Massachusetts, and now I'm down here. Yeah.
And what drew you down to the Chesapeake Biological Laboratory?
Well, in undergrad, I kind of didn't really know what I wanted to do. I knew I was interested in environmental science, but I wasn't really sure how to go about that. And then, of course, grad school became the option, and how to continue and pursue further environmental science issues and whatnot. I was a chem major in undergrad, and it actually happened to be that one of my favorite teachers. She was kind of a mentor to me. She actually ended up getting her PhD at CBL, and it totally happened by accident because when I went to her, like, can you write me a letter of recommendation for grad school, please? I'm applying to these places. And she was like, oh my God, that's where I got my PhD, like that lab and everything. I'm like, no way. So
That's
it's kind of,
amazing.
yeah, it's kind of funny that it worked out that way. But mostly what drew me down here was that, I mean, I came from a small undergrad, as I mentioned, and I actually hadn't made my decision until graduation day. I was like, walking around, I was thinking like, wow, I really love this small community feeling. And I really want that wherever I go next, I really want to like have that feeling with me. So CBL was, a kind of another perfect small little community for me to get myself into. And then as well as that, the research was just too good to pass up. So the research opportunity was really exciting, and it still is exciting. So I'm pretty
And
happy with that.
what research opportunity are you pursuing? And who are you working
So,
with?
okay. I'm a master's student with Dr. Michael Gonsior. Dr. Michael Gonsior, he's a really cool scientist. He's done a lot of really cool work, but right now we're working on some chromophoric dissolved organic matter research, or essentially dissolved organic matter research. So if you think about how carbon cycling is, oceans are a carbon sink. And so any CO2 that's in the atmosphere can be taken up by the ocean. But once it's in the ocean, it can take like many pathways, many forms. But 80% of the organic forms in the ocean are kind of unknown. Like, we don't really know their structure. Therefore, we can't know how they react and how they behave and where they go. So our research essentially is kind of like connecting picocyanobacteria, or forms of life that can take up the CO2 that is drawn from the atmosphere, and then essentially digests it down into the ocean. And once it's digested, we're trying to see, how to like track it and how to better understand it and get a molecular structure, so we have a better understanding of its behavior. And the implications are really important right now, because as CO2 levels are rising in the atmosphere, I mean, we don't know how much carbon that the ocean can hold and uptake, but also, does that carbon ever actually leave? Like, how long can the carbon stay in the ocean for? And what form does it sort of leave with? Does it go into the sediments, into geological record, or are we looking at sources elsewhere? Or so it's all very interesting, and it's cool thing about the carbon cycle is that it's all connected. So
So you're really researching that the question mark in the carbon cycle in a way.
oh
Um,
yeah.
and you mentioned as the world's carbon dioxide levels increase, that this is an increasingly important topic. How could your research play out in the real world? Why should someone who isn't a scientist care about what you do?
Um, Let me think about that one for a second. I mean, it's of course it's important because as CO2 levels rise in the atmosphere, you're concerned about global warming, because CO2 is a greenhouse gas. And so increasing amount of greenhouse gases, meaning we have warmer temperatures, and there's feedback effects. So essentially, you change one thing about the planet, a lot of things are going to change along with it, and they may not necessarily be good. So, but the cool, interesting thing is that because we're looking at picocyanobacteria, if we're looking at a warming Earth or a warming globe, we might actually also see an increase in productivity in the picocyanobacteria, like forms of life that can uptake CO2 because they prefer like, slightly warmer conditions. They're a little tropical kind of, they like that beach life. But the thing is that, there's a feedback that might not say like, it may not be helpful for them, it might hurt them. So we don't really know how the earth is going to continue to complete these processes, like, such as the carbon cycle, everything that all the processes that make up these cycles that cycle are all of our nutrients. We don't really necessarily know how the earth is going to, react to the global changes that are happening. And, going forward, it's really important to know the kind of behavior that carbon in the deep ocean has, so that way we can have a better understanding of like, if things were to change, how might they change and what can we expect in the future.
So, Maddy, what are picocyanobacteria?
Picocyanobacteria are essentially like phytoplankton. They're like little tiny invisible, I mean, naked to the, or invisible to the naked eye. And they're in kind of the top or upper layers of the ocean. They really like sunlight, they complete photosynthesis, and they live their life. And, once they die, they kind of get digested, or, they sink. And that's how the carbon travels from upper ocean down into the deep ocean, which is what I'm interested in.
That's a perfect explanation.
So.
So, Maddy, what do you think is cool about your research that a non-scientist would be interested in?
I mean, what's not cool about my research? It's really cool talking about how everything's connected, but it can, like, the project itself is really specific, and so it's really cool learning about the what we can do to kind of help, answer the question mark, like answer these questions. And so part of my project is I'm taking a look at biotracers, and so it's cool that we have these chemical structures or compounds that they're persistent through each of these stages, or each, as they sink down into the deep ocean. And that's something I'm learning more about myself right now, rather than something I've already come into this knowing. And I mean, that's a big part of grad school, coming in with little knowledge and really, really jumping into it. So that is really cool. But I mean, I guess what else is enticing about it is I was able to go to Bermuda for sampling. We went on a research cruise, and that was a whole new world for me. I had never done that. And it was a really great experience. And we're actually trying to sample again in the Pacific Ocean. So the Bermuda's in the Atlantic Ocean. And we'd be flying to Hawaii, hopefully this upcoming summer, depending on how the state of the world and COVID-19 is going. But ideally, we'll be sampling in the Pacific this summer. So we have some samples to compare in the Atlantic versus the Pacific, because their ocean circulations are very different, and the Pacific is much deeper and has older carbon. So it'll be very interesting to compare those two. But as a non-scientist, you might be like, oh, cool, like you get to go on a boat and take samples. So.
Well, that does sound like it would be a cool point of comparison. So as your career continues to develop, what would you ultimately like to be doing?
I don't know. I'm kind of really enjoying the moment and the research that I've got going on right now. I know I have a little bit of time before I really need to figure out what I want to do, but I'm considering options. And, there's always the idea of pursuing a PhD after finishing my master's. There's always policy work. There's some fellowships that I might consider applying to. But I am keeping my options open.
And what advice would you give to a kid, or say a 10-year-old who's interested in a career in chemistry, or more generally science, technology, engineering, and math?
Yeah, I would absolutely recommend to nurture your interest in that's not necessarily in ways that are through school. So school, you might be assigned a book to read, and you're like, I don't want to read this book. Like, like you're kind of dreading it, like whatever. You might be enjoying it while you're reading it, but you dread it kind of in the beginning. Like maybe not everyone, but that's how I felt. So what I had to do was, a lot of times I would find interests in science that weren't related to school. And that helped me bolster my experience in science a lot, because, whenever I came across a topic, I was like, wow, I read a book about this years ago, and now it's helping me a lot. And I really understand, or I like that it's connected to this. And you get a better, more wholesome understanding of science in that way, while also not, overworking or killing your interest.
That's a great way to explore your interests and to really develop your understanding of topics that you find fascinating. Maddy, I wish you the best of the luck as you continue to conduct your research and pursue the things that you find fascinating in life. Thank you so much for taking the time to speak with me today.
Yeah, thank you so much for having me, of course.
All right, thank you, Maddy, and thank you everyone for joining us.